Hi guys, we're back for our next day. How are you guys all doing? If you need anything, please make sure you're letting us know. You can always respond to these on the comments, or you can email me or message me on Google Hangouts. So this is your warm-up. Once again, I'm going to get started. You can pause as needed. I just want to make sure we get a video in for you guys. It's kind of efficient. So the first part here is talking about area. So remember, when we do area of a rectangle, that's going to be base times height. So here our base is 9 meters. Our height is 4 meters. 9 times 4 is 36. Remember, because it's area, we could say it's meters squared. Our next one's the square. Area of a square is area equals side squared. Area equals, our side length here is 13 yards. We're going to square it. That gives me 169 yards squared. Our next one here, this does look a little misleading. So this 4 goes to this portion here. So for area 1, it's a square, and we see area 1 is going to be 4 centimeters times 4 centimeters, which is going to be 16 centimeters squared. Our second one down here, you see this is 2 centimeters, and then this 10 corresponds to this side. So I'm going to call that area 2. Area 2 is 2 centimeters times 10 centimeters, which is going to give you 20 centimeters squared. And last but not least, this 2 corresponds with this side, and that 8 corresponds with this side. So area 3 is going to be 2 centimeters times 8 centimeters, which will give me 16 centimeters squared. Once again, with this, we see that 16 plus 20 plus 16 is going to give me 52 centimeters squared. It's a little weird doing this without your guys' voices. I hope you guys are really doing well, and then we can get back in the classroom soon. Here is a triangle. Area of a triangle is slightly different. Remember, that's 1/2. Base times height. So I have 1/2. My base length here is this whole length, 18 inches. And then the height is to the tallest part of the triangle, which is this 5. We see that 2, or 1/2 of 18, I look at it that way, 1/2 of 18 is 9. So we have 9 times 5, which is 45 inches squared. Okay, so again, this is the bell ringer. Make sure you're pausing it if you need it, and leaving me with questions. If you have more questions, I'd love to answer them. Since I'm doing this from an iPad now instead of a desktop, it's a little bit harder to get the pictures to look exactly right, so you notice that my slides are a little bit off to the side. I'll try to be better at centering them. But today we're doing 8.5 area parallelograms. And because we had a pie day last weekend, Yusef came in today and told me a math joke. So Sierra, this one's for you. What do you call a snake that's 3.14 meters long? Okay, I'll tell you in a minute. So as you're waiting and thinking about, what could be the answer to this really funny joke? You ready? It's a python. I hope you guys are enjoying it. If you have more math jokes, you know Jenkins loves to hear them. Okay, so we have some keywords here. Bases of parallelogram. So either pair of parallel sides of a parallelogram are considered to be the bases. The height of the parallelogram is the shortest distance between the two bases, or between the bases of a parallelogram. The height is perpendicular to the bases. Okay. Again, you should pause it. I'll try to give you guys a little bit of time to write this one down. Okay, and then area of a parallelogram. The area of a parallelogram is base times height. But notice here that you have your base, and then your height kind of looks like the height of a triangle like we had before. So parallelograms have both pairs of opposite sides congruent. Both pairs of opposite sides are parallel. And then it has all the other features that we talked about. Opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. Okay, so page 1 of your notes are done. So now we're going to go on to example 1. So area of a parallelogram is base times height, just like a rectangle. And we see here our base is going to be that 5. And our height is the 9 meters. It's the shortest distance between those two bases. Base is 9 meters, which gives me 9 times 5 is 45 meters squared. Over here, we have a base that is 17 centimeters, and we have a height of 12 centimeters. So to find our area, we have 17 centimeters times 12 centimeters. Again, feel free to use your calculators or your cell phones, whatever we're using as calculators here. 17 times 12, I got 204 centimeters squared. Again, it's still area, so make sure we put that square on our units. Like every other section we have, now as we're going backwards, we're given the area, and we're missing a piece of this. So we see that area equals base times height. We know our area is 63 meters squared. We know our height is 9 meters, and our base is being represented with a B. I'm going to divide each side to get that B isolated by that 9 meters. You have meters squared on top and meters, just a meter on the bottom, so those are going to go away. And then 9 goes into 63 4 times. So we see that our base is going to be 4 meters long. Okay, our next one, we're missing the height. We have the base this time. So you're going to use that same formula. Area equals base times height. Area is 144 feet squared. Our base is 16 feet. And our height is h. We want to get that h isolated, so we're going to divide each side by 16 feet. You see that both feet, and then there's a feet, the numerator and denominator. So 1 foot cancels with the square of the numerator. And then we look to see how many times 16 goes into 144. So let me put that in my calculator. 144 divided by 16 gives me 9. That's a terrible 9. 9 feet. So my height is 9 feet. And last but not least, we have area equals base times height. Area is 55 centimeters squared equals my base of, that base looks like a 5. I can see where that could be confusing, so I'm just going to fix it, BH. And my base here is just B. My height is 5 centimeters. We're going to divide each side by 5 centimeters. We see that in our numerator, we have centimeters squared, a centimeter in our denominator. 5 goes into 55 11 times, so my base is 11 centimeters. Okay, we're almost done with this half. We're going to switch now to area of a rhombus. Okay, so now area of a rhombus. So area of a rhombus is 1/2 diagonal 1 times diagonal 2. So when it's talking about diagonal 1 and diagonal 2, it's talking about these. Remember, diagonals join non-consecutive vertices. So we have one diagonal here and we have the other diagonal here. This is essentially doing the same thing as finding the triangles, but this makes it a little bit easier and quicker to find. So 1/2 D1 times D2, where the D's are diagonals. Okay, using the fact that our formula is going to be area equals 1/2 D1 times D2. We see that these are the lengths here, that 14 represents this length, 14, and then this one would be that 8. They just did not represent inside of the rhombus. So we can substitute those in. Equals 1/2 8 meters times 14 meters. We see 1/2 of 8 is 4. So you have 4 times 14. 4 times 14 gives me 56 meters squared. Here, though, we have to do some math to do this. You still have the area equals 1/2 D1 D2. So our D1 here is 3 plus 3. So we have 1/2 of 6 feet times, and then our second diagonal is going to be 6 feet plus 6 feet, which is 12 feet. Half of 6 is 3. 3 times 12 is 36. And then again, it's area, so we have that as feet squared. Okay, so this again is for a rhombus, and we have another area formula being introduced on our next slide. Okay, so we're just referring to this as a regular polygon. So a regular polygon has several parts. So we can look here, and you see the central angle. It's the one occurring from the center dot, and then the line from the center to the edge. We call that the radius. You guys have heard about that in circles before. And then we have our A, or our apothem, over here. So you see that is going to be what forms that right angle all the way down. So that's your apothem. So area equals 1/2 apothem times perimeter. So that P stands for perimeter. Okay, and so now this is our last example. I had to write this out again, so I remember area equals 1/2 apothem times perimeter. You see that we have area equals 1/2. Our apothem is the 6. That's the thing forming that perpendicular line. And so we have 6. No units are on this one. And then we have to find out our perimeter. So remember, every time we do perimeter is the amount of fencing it requires. So we have a 5 plus 5 plus 5. It says it's regular, so remember that means all the side lengths are congruent and all the angles are congruent, plus 5, and then the last one's going to be 5. And we see that makes 25. So 25, half of 6 is 3. 3 times 25, so if you have 3/4, it's 75. And we don't know what it is, so it'd be units squared. Okay, guys, thanks again for watching this video today. I hope you paused it as needed. Please be safe, make good decisions, wash your hands, and let me know if you need anything. Miss you.